Welcome to part 2, Instantiating and Running Cases Model. So we just covered what's inside the Cases Model class. In this section, we're going to instantiate the Cases Model, and then we're going to call the run method to actually run all the procedures inside of it. Okay, so before we do that, we need to get our data, and our data is gathered through this prepare data class, which has a run method. So we're going to call that first, get our data, which is a dictionary of 4 keys mapped to data frames. We're going to then instantiate the cases model right here. We're going to pass it in the general logistic shift function, although it can be any model. We're going to give it our data, our dictionary of data frames, the last date of training, so we're going to pick November 5th, 2020, the number of training days to use before that, so it's going to use the previous 60 days before to train on, the number of days to smooth the data, so we're going to use 15 points to smooth the data in its low-S smoothing, the number of days to predict into the future, and we'll predict 30 days into the future, and then some parameters to help us determine the bounds for our parameter L, the lower and upper bound. So we're going to look at 5 days of exponential growth for the lower bound of L and 50 days for the upper bound of L. Okay, so let's go ahead and call this. Now, instantiating the cases model class does not run really anything. And if we take a look above of what happens during instantiation, very little happens. So this is under this dunder init method. So you can see over here, it just essentially stores the attributes. It does get the last date, and it creates the date range. So that's all it does. The bulk of the work is in this run method, which we must call independently. And that's what we're going to do now. So it's going to go through, again, every area from the USA cases and the world cases, smooth the data, train the data, and then make predictions, and then save all the results. Let's go ahead and call this run method, which will take some time. It takes about 25 seconds on my machine because it has to go through every single area and like every single country. I think there's around 200 countries in every single state, and there's more than 50 states. There's some territories for the USA. So we'll just wait until this completes, and then we'll look at the results. Okay, so it's finished doing all of that work. It's quite a lot of work. So it's got to build a model for all those areas. So let's go look at the results. So now everything is contained in this CM variable. So I decided to call it CM. This is the instance. So that's the instantiating part. And then we just did the run. So CM now holds all of the information. So our original data is in that CM.data. So that is static and nothing happened to that. But just so that we can look at it, here is the last 5 rows from the world cases. So up until the very last time this was run. So if you change this prepared or download new into true, you'll get whatever current date is. So this is the last day that the data was updated before this video. So up to February 3rd. And we were just looking at the first 10 countries. That's what we have here. So now let's look at the smoothed data. The last 5 rows. Again, this is before prediction, so this is up to November 5th. So for the first 10 states, this is the cumulative smoothed number of cases. So that's in that smoothed attribute from the cases model instance. And so we have attributes for for so many different things. So here are the other ones for the bounds. So this is we're looking at world cases, and we're looking at just the just all the variables over here. So these go into the general logistic model, and you can see there's a lower and upper bound for every variable for every country over here. Now x naught, k, and v will be the same for all of them, but the major one is L. This is really the one that matters. So we can see here the lower bound is 42,000 for Afghanistan, and it's actually a pretty tight bound over here, 47,000 as the upper bound. So that it must be in a period of low growth. Albania is a much wider band, 25,000 to about 55,000, and so forth. That's pretty cool. You can see what parameters were actually used. And let's go ahead and look at the initial guesses for the parameters. So we can take a look at that. Again, x0 through v will be the same, but the initial guess for L and the vertical shift upward will be different for each one. We can see here that the model guessed at 45,000 for Afghanistan for the initial one. Then we can look at the predicted values. So the very first, we look at the first 5 predicted values for the first 10 countries, or for the first 10 states over here. And so you can see those right there. And these are daily predicted values, so that's a big difference. So that's why you see like they may not be increasing very much, but the model is essentially predicting just about the same number for some of these. California is a little bit different. Looks like it's in a little bit of a decline at this stage. Colorado is looks like it's in a stage of increase. All right, now we can look at the predictive cumulative. So this is just the cumulative, not the daily. And then we have a data frame that combines the actual and the predicted into a single data frame. So if you remember, our last training date was November 5th. So I'm just looking at a small window over here, November 3rd through November 8th, up into a particular state. So I just said up until Delaware. And you can see that our model is actually significantly different than, this is for the daily cases. So if we're looking at Alabama, so it looks like things are perhaps decreasing. It's hard to tell. We don't have, didn't set the window to a little bit higher. But anyways, our model is predicting this, and this is what actually happened in the 3 days before. So they should be pretty close. Looks like California is significantly different. So maybe looks like our model has made a bad prediction over here. But that's sometimes what happens. All right, so let's look at combined cumulative. Pretty much the same thing, but just a cumulative basis. And then we also have combined cumulative for the smooth. That's for this little S over here. So for the smooth daily cases and the smooth cumulative as well. Okay, so those are all the results after running that you get. So you get all this information back that you can look through for every single case. So it's just kind of compiled all the information together in these data frames. And the last thing we can do is, of course, plot the prediction. So this is the same method that was defined before in previous chapters. And in this case, you have to give it the the group, either USA or world, and then the particular state or country. And we can see over here, we have the actual in blue and the orange are predicted, and it has the right direction. Didn't quite get the right trend correct for Texas in this instance. And you can see here that it starts right at November 5th for the predicted. All right, so that is the instantiation of, and then the running of, and then the looking at the results of our new cases model.